In a remarkable intersection of art, science, and exploration, NASA has unveiled a plethora of initiatives that highlight humanity's ongoing quest to understand our planet and beyond. As we navigate through April 2025, a series of advances in space exploration, environmental monitoring, and even the burgeoning field of space tourism have captured the public's imagination. One of the more eye-catching features of NASA's latest endeavors is the Astronomy Picture of the day, which recently showcased an unusual hole in the Martian landscape. This image, taken by NASA's Mars Reconnaissance Orbiter, reveals a Swiss cheese-like terrain peppered with holes, the most striking of which spans approximately 100 meters. This particular pit, which appears to penetrate deeper layers of Martian terrain, is believed to have been formed by a meteor impact. Scientists are particularly intrigued by these holes, as they could potentially serve as access points to subterranean caves that might harbor signs of past or present Martian life. Such findings not only ignite curiosity about the red planet but also set the stage for future exploratory missions involving both robotic and human explorers. Meanwhile, the realm of space tourism is experiencing its own moment of transformation. On April 14, Blue Origin is set to launch its 11th crewed spaceflight, featuring a completely female crew for the first time since Valentina Tereshkova's historic flight in 1963. The mission will include notable personalities such as pop star Katy Perry and journalist Lauren Sanchez, highlighting a growing trend towards gender inclusivity in the space sector. Despite the excitement, some skeptics question the significance of an all-female crew in an era when female astronauts are becoming increasingly commonplace. As former astronaut Marcia Ivins noted, the focus should be on the capabilities of the crew rather than their gender. Nevertheless, the mission is expected to generate interest in commercial space travel, which promises to make space more accessible to a broader audience. In a different yet equally fascinating application of NASA technology, researchers are utilizing lunar observations to enhance satellite monitoring of Earth's environment. The recent Airborne Lunar Spectral Irradiance air-LUSI mission involved NASA's ER-2 aircraft flying beneath a waxing moon to gather data that will refine the calibration of Earth-observing satellites. This innovative approach not only improves data quality but also reduces costs associated with satellite missions. As Kevin Tepe, the principal investigator for air-LUSI, stated, the moon serves as a perfect benchmark for accurate measurements of Earth's processes, providing a consistent reference point that can lead to significant advancements in our understanding of the planet's ecosystems and climate. Additionally, NASA's research is making strides in predicting wildflower superblooms, leveraging advanced imaging technology to monitor blooming patterns across California. Utilizing a sophisticated imaging spectrometer, scientists can track seasonal cycles of flowering plants with unprecedented accuracy. This capability holds great promise for agriculture and conservation, aiding farmers in planning harvests and helping ecologists manage ecosystems. Yoseline Angel, a lead researcher on the project, emphasized the potential for citizen scientists to contribute by reporting local blooms, thus creating a collaborative effort to enhance scientific understanding of these events. As we look to the future, it is clear that NASA's diverse initiatives are not only pushing the boundaries of exploration but also fostering a deeper connection to our planet and beyond. The implications of these projects extend far beyond their immediate scientific goals, inspiring a new generation of explorers and researchers while addressing some of the most pressing challenges faced by humanity. Whether it is through the exploration of Mars, the democratization of space travel, or the intricate monitoring of Earth's ecosystems, NASA continues to lead the charge in our quest for knowledge and understanding. As we stand on the brink of these exciting developments, one can only wonder what new frontiers await us in the cosmos and what discoveries lie just beyond the horizon. In a remarkable demonstration of human ingenuity and exploration, recent space missions and discoveries have captivated the public's imagination, underscoring the intersection of science, technology, and the quest for knowledge beyond our planet. From intriguing discoveries on Mars to pivotal partnerships shaping future space research, the current landscape of aerospace exploration is abuzz with activity as organizations aim not only to push the boundaries of science but also to foster greater inclusivity in space travel. On April 13, 2025 NASA's Astronomy Picture of the Day showcased a striking image of Mars featuring an unusual formation described as a hole in a landscape resembling Swiss cheese. This peculiar geological feature spanning approximately 100 meters is believed to be linked to meteor impacts, leading to speculation about the possibility of underground caverns that could harbor Martian life. As NASA's image highlights, such formations are not merely geological curiosities, they represent potential gateways to understanding the planet's past and the conditions necessary for life. These discoveries may attract future missions and exploration efforts, making them prime targets for spacecraft, robots, and even human explorers. Simultaneously, the ongoing collaboration between VAST and the Center for the Advancement of Science in Space (CASIS) marks a significant advancement in research capabilities aboard the International Space Station (ISS), announced on April 14, 2025. This partnership aims to enhance access for new participants in space research, aligning with NASA's goals for its private astronaut mission ecosystem. Max Hout, CEO of VAST, emphasized the importance of this agreement, stating, "It enables us to fly science, validate our technologies in microgravity, and continue close collaboration with NASA." This partnership not only bolsters VAST's ambitions but also reflects a broader trend toward commercializing space, enabling a diverse range of organizations to contribute to scientific endeavors in low Earth orbit. In a striking juxtaposition of past and present, Blue Origin prepares for an all-female crewed flight scheduled for April 14, 2025. While this mission may not capture the same level of attention as historic flights, it represents a significant milestone in the acknowledgement of gender diversity in space exploration. The crew, comprised entirely of women, is set to embark on a brief suborbital journey, a feat that recalls the pioneering spirit of early astronauts. As Gail King, a member of the crew, noted, "These women are so badass, they have such amazing life stories." Yet some commentators question the emphasis placed on the crew's gender, suggesting that the focus should rather be on their capabilities as individuals irrespective of gender. Meanwhile, the recent return of NASA astronauts Butch Wilmore and Suni Williams, who spent 9 months aboard the ISS, has sparked discussions about astronaut remuneration. Despite the extended duration of their mission, NASA clarified that astronauts do not receive overtime pay, as they are considered federal employees on official travel. Their base salaries, alongside a daily allowance for incidentals, highlight the structured nature of compensation in the space industry. This revelation sheds light on the complexities of supporting long-duration missions and the commitments made by astronauts in the name of exploration. As advancements in space exploration continue to unfold, the importance of collaboration, inclusivity, and scientific discovery remains paramount. The interplay between private companies and governmental agencies is shaping a new era of exploration where diverse voices and innovative technologies are essential to addressing the challenges and opportunities of the cosmos. As we look to the stars, the potential for groundbreaking discoveries and the realization of human ambition in space seem brighter than ever. Future missions, collaborations, and the pursuit of knowledge will undoubtedly pave the way for humanity's next great adventures beyond Earth. As NASA astronauts Butch Wilmore and Suni Williams return to Earth after an unprecedented 9-month mission aboard the International Space Station (ISS), questions arise about their compensation for this extended period in space. After a prolonged journey that began in June 2020, the crew safely splashed down off the coast of Florida on March 18, 2025, alongside fellow astronaut Nick Hague and Russian cosmonaut Alexander Gorbanov, who had been in orbit since September. Despite the remarkable and arduous nature of their mission, the issue of astronaut pay reveals a surprising reality. According to NASA, astronauts do not receive overtime pay even when their missions exceed the expected timeframe. When NASA astronauts are aboard the International Space Station, they receive regular 40-hour workweek salaries. They do not receive overtime or holiday/weekend pay, the agency clarified in a statement. Instead, astronauts are considered federal employees on official travel orders, which cover their transportation, lodging, and meals while in space. They also receive a daily incidental allowance, albeit at a reduced rate based on the length of their mission. Astronauts typically fall under the general schedule GS pay grades of 12 to 13, an echelon that corresponds to highly educated professionals with advanced degrees and specialized training. For 2024, the salary for these positions ranges from approximately $100,287 to $155,034, with an average annual salary reported at around $152,258. For Wilmore and Williams, their time in space could yield a modest additional amount for incidentals. A former astronaut indicated that her daily incidental allowance was around $4. If this were applied to the 286 days spent in space, it would total a supplemental $1,144. As these astronauts readjust to life on Earth. Their departure from the ISS coincided with the arrival of another crew on March 14, part of a joint SpaceX and NASA mission. This latest team includes astronauts in McLean Nicole Ayres, Jax's Takuya Onishi, and Roscosmos's Kirill Peskov, continuing the cycle of human exploration in orbit. In a different sphere of space exploration, Blue Origin is preparing for its upcoming crewed flight scheduled for April 14, 2025. This mission will notably feature an all-female crew, a first since Valentina Tereshkova's historic solo flight in 1963. While the significance of an all-women crew is acknowledged, there are mixed feelings about framing it as a groundbreaking event. Critics argue that the emphasis on gender distracts from the broader advancements in space travel and the qualifications of the astronauts themselves. Among the crew are notable figures such as pop star Katy Perry and television personality Gayle King, who expressed excitement about participating in this mission. King remarked, "These women are so badass, they have such amazing life stories, all that they've accomplished." This flight aims to showcase female empowerment in a field that has historically been male-dominated, yet some voices within the astronaut community call for a focus on capability over gender. In the spirit of inspiration, NASA astronaut Jeanette Epps recently returned to her hometown of Syracuse to engage with students at her former high school. Epps, who has made significant contributions to space exploration, emphasized the importance of hard work and ambition to the students, many of whom may now see a pathway to careers in STEM fields. "Whatever you want in life, you're going to have to work hard for it," she advised. As space exploration continues to evolve both in terms of who participates and how they are compensated, the future promises to be filled with new milestones. With plans for Artemis missions that aim to return humans to the moon, including the first woman and the first black individual to land there, the narrative of inclusion and diversity in space is set to expand. As we look ahead, the developments in both NASA's ongoing missions and the burgeoning commercial spaceflight sector will be pivotal in shaping the next chapter of human exploration beyond Earth. In an innovative leap towards enhancing satellite Earth monitoring, NASA has harnessed the power of moonlight, transforming its ER-2 aircraft into a unique lunar observatory. This endeavor, conducted in March 2025, is part of the Airborne Lunar Spectral Irradiance mission, commonly referred to as air-LUSI, and represents a significant advancement in the accuracy of Earth observations. Flying at altitudes nearing 70,000 feet from NASA's Armstrong Flight Research Center in California, the ER-2 aircraft captured moonlight across various wavelengths and phases using a precision spectroradiometer. This instrument meticulously records the sun's reflected light from the moon's surface, thereby allowing researchers to calibrate Earth-observing satellites with an unprecedented level of accuracy. Kevin Tuppy, the principal investigator for air-LUSI at NASA's Goddard Space Flight Center, emphasized the moon's role as an absolute reference for satellite measurements. He noted the moon also becomes the perfect benchmark for satellites to consistently and accurately measure processes on Earth. This consistency is critical as satellites monitor vital aspects of our planet, including weather patterns, ecosystem health, and ocean dynamics. The high-altitude flights ensured that measurements were minimally affected by atmospheric disturbances, resulting in data of remarkable clarity. Kelsey Bisson, a NASA program scientist involved in the project, stated, "To date, air-LUSI measurements of the moon are the most accurate ever made. This new methodology not only enhances our understanding of Earth's systems but could also lead to significant cost savings by decreasing the reliance on expensive onboard reference devices and satellites. The air-LUSI project is a collaborative effort involving several prestigious institutions including the National Institute of Standards and Technology (NIST), the U.S. Geological Survey, the University of Maryland, Baltimore County, and McMaster University in Canada. The latter played a pivotal role by developing sophisticated hardware for the campaign, including an autonomous robotic telescope mount instrument system and the high-altitude aircraft-mounted robotic HAMR telescope mount. These technologies facilitated precise tracking of the Moon during flights, marking a significant milestone in airborne lunar observation. Andrew Gadsden, an associate professor at McMaster University and co-investigator on the project, remarked on the significance of this cross-border collaboration, stating, "The collective effort of the American and Canadian team members offers an opportunity for truly exciting engineering and science collaboration." Meanwhile, John Woodward, another co-investigator, expressed optimism about the future, asserting that these highest accuracy measurements of lunar light will lead to improved Earth observation systems. As NASA continues to refine its satellite calibration techniques through moonlight observations, the implications for Earth science are profound. This pioneering approach not only enhances our understanding of the planet but also sets the stage for future developments in satellite technology and environmental monitoring. As we look ahead, the potential for more accurate predictions of climate-related phenomena and their effects on ecosystems becomes increasingly viable, paving the way for informed decision-making in an era of rapid environmental change. In an era where the boundaries of space exploration are being pushed further than ever before, recent discoveries and advancements from NASA highlight both the mysteries of our solar system and the capabilities of our technology. As we delve deeper into the cosmos, the implications of these findings could reshape our understanding of planetary life, the potential for human colonization, and the methodologies we use to study our home planet from afar. One of the most striking images released by NASA's Astronomy Picture of the day on April 13, 2025 features an unusual hole on Mars set against a backdrop of a Swiss cheese-like landscape. This intriguing geological formation, measuring approximately 100 meters in diameter, is believed to be the result of a meteor impact. Beneath the dusty dark surface, which is currently covered by evaporating carbon dioxide ice, lies a lower level that could potentially connect to expansive underground caves. Such formations are not only of scientific interest but could also be crucial for future exploration, as they offer a relatively protected environment that might harbor Martian life. These naturally occurring tunnels are prime targets for possible future spacecraft, robots, and even human interplanetary explorers, indicated the astrophysicists involved in analyzing the data. In tandem with Martian exploration, NASA's recent efforts have also extended to refining Earth monitoring through lunar observations. In March 2025, the agency launched a mission called Airborne Lunar Spectral Irradiance (air-LUSI), utilizing the ER-2 aircraft to gather moonlight data. Equipped with a precision spectroradiometer, the aircraft soared at altitudes of nearly 70,000 feet, capturing moonlight across various wavelengths. This innovative approach allows scientists to use the Moon as a calibration benchmark for Earth-observing satellites, enhancing the accuracy of data related to weather patterns, ecosystems, and ocean dynamics. As an absolute reference, the Moon also becomes the perfect benchmark for satellites to consistently and accurately measure processes on Earth, explained Kevin Tuppy, the project's principal investigator. Meanwhile, on the administrative front, the nomination of Jared Isaacman as NASA's new administrator has stirred conversations regarding the agency's priorities. During his Senate confirmation hearing, Isaacman acknowledged the dual ambition of advancing the Artemis program for lunar exploration while also expressing a desire to send astronauts to Mars. Senator Ted Cruz pressed him on maintaining focus amidst these competing goals. Sending U.S. astronauts to Mars was a priority, and along the way we will inevitably have the capabilities to return to the Moon, Isaacman stated, highlighting the complexities of balancing such monumental objectives. The interplay between lunar and Martian exploration reflects a broader narrative in space policy where the quest to establish a human presence on the Moon serves as a stepping stone toward more ambitious missions to Mars. As technological advancements continue to evolve, the prospect of sustained human activity on these celestial bodies becomes increasingly plausible. Looking ahead, the ongoing investigations into Mars's surface and the Moon's light will not only enhance our scientific understanding but also inform the strategies we adopt in addressing the challenges of interplanetary travel and habitation. The future of space exploration promises to be as exciting as it is uncertain, with each discovery paving the way for new questions and endeavors. As we continue to uncover the secrets of the universe, the potential for human expansion beyond Earth remains a tantalizing possibility that is firmly within our grasp. In a remarkable display of scientific exploration, NASA is shedding light on the mysteries of our solar system with two notable projects that highlight advancements in space observation and planetary research. As interest in the cosmos continues to grow, these initiatives not only deepen our understanding of celestial bodies but also pave the way for future missions aimed at uncovering the secrets of the universe. On April 13, 2025, NASA's Astronomy Picture of the Day featured a stunning image of an unusual hole on Mars which has sparked curiosity among scientists and space enthusiasts alike. This peculiar feature, part of a landscape reminiscent of Swiss cheese, showcases multiple holes, with one in particular measuring about 100 meters across and appearing to connect to lower subterranean levels. The prevailing hypothesis suggests that this hole may have been formed by a meteor impact surrounded by a circular crater that adds to its intrigue. Such formations are not merely geological curiosities, they are critical in the search for Martian life. Researchers believe that these holes could serve as natural tunnels, potentially harboring conditions suitable for microbial life, thereby making them prime targets for future exploration by spacecraft, robots, and possibly human explorers. The implications of this Martian discovery extend beyond mere curiosity. As scientists ponder the potential for life beneath the surface, they also consider how these underground environments could offer protection against the harsh conditions on the Martian surface, which is characterized by extreme temperatures and radiation. Understanding these features is vital for planning future missions aimed at searching for signs of life on Mars, a goal that continues to captivate the imagination of scientists and the public alike. Meanwhile, on a different front, NASA's innovative use of moonlight is revolutionizing Earth monitoring capabilities. In a groundbreaking mission called Airborne Lunar Spectral Irradiance air-LUSI, NASA's ER-2 aircraft recently flew beneath a waxing moon, effectively transforming into a lunar observatory. Equipped with a precision spectroradiometer, the aircraft collected moonlight data at various wavelengths, which is being used to calibrate Earth-observing satellites with unprecedented accuracy. Principal investigator Kevin Tuppy remarked as an absolute reference, "The Moon also becomes the perfect benchmark for satellites to consistently and accurately measure processes on Earth." This innovative approach not only enhances the quality of satellite data but also promises to reduce costs by minimizing the need for onboard reference devices. Flying at altitudes near 70,000 feet, the ER-2 aircraft provided a clear vantage point, allowing for measurements largely free from atmospheric disturbances. NASA program scientist Kelsey Bisson noted, "To date, air-LUSI measurements of the Moon are the most accurate ever made," emphasizing the project's potential to improve our understanding of Earth's processes from weather patterns to ecosystem dynamics. The collaboration extends beyond U.S. borders, with contributions from the National Institute of Standards and Technology, the U.S. Geological Survey, and McMaster University in Canada. This joint effort exemplifies the international spirit of scientific inquiry, as highlighted by McMaster's Andrew Gadsden, who remarked on the exciting engineering and scientific collaboration involved. As we look to the future, the discoveries being made through these projects not only enhance our scientific knowledge but also lay the groundwork for future explorations. The quest to understand Mars and refine Earth observation techniques signifies a pivotal moment in space exploration, inviting both scientists and the public to engage with the mysteries of our universe. With every discovery, we move closer to answering fundamental questions about our place in the cosmos and the potential for life beyond Earth.